Okay, I'm going to do the same problem now using vector loops. You still have to go in and determine whether or not you need to do a free body diagram. If you're not sure how to do that, see the previous video on doing this problem with special points. But anyway, because it's 1 degree of freedom and because you're given one velocity, you can find any velocity you want without needing a free body diagram. Okay, to do the vector loop, you have to be able to see how to walk around in a loop. And if you can't see that, some problems, it'd be obvious that it's difficult. But there's some, in class I'll cover more details. But basically, you can start anywhere you want, and you basically walk around the diagram, and you return to your starting point. So in this case, I'm going to start at C, this point right down here. I'm going to go to B, and then I'm going to walk to A, and then I'm going to walk to C, and then I'm done with my loop. Okay, so let's do that. So if you start at C and you want to get to B, you're going to walk a distance dB, right? So, label your distances dB, and dB is going to change, so I'm going to keep in mind that that's a variable. But when I go a distance dB, I'm going to go down sine of 30, and then I'm going to go left cosine 30. So I'm going to go distance of cosine 30, left, negative I, and I'm going to go a distance of sine 30, down, negative j. Right? So now I'm standing at B. Now I want to walk up to A. To walk up to A, I'm going to use the variable from this link. Okay? So I'm going to go a distance of 5. I'm going to go sine of theta, that distance, to the right. That's why it's a positive I to the right. And then I'm going to go up, positive j, a distance of cosine theta. Right? So now I'm standing at A. Then I want to walk back to C. So I'm going to go down, negative j, and we'll go a distance of YA. So I'll label that guy as YA, that distance there. Set that equal to 0 because I'm back at my starting point. Again, you can start anywhere you want as long as you will go all the way around the circle or triangle or whatever it is and come back to where you started. Okay, the next step is you take derivatives. So you cannot plug in, since you're going to take derivatives, you cannot plug in 50 degrees for theta yet. You have to wait until after you take your derivative. Okay, so here we go. We're going to take a derivative. So dB is a variable, so you get a dB, a dot, right? Don't forget the chain rule. And then this is all constant, so that doesn't change anything. And then, you have 5, that's a constant. And now you take a derivative of each one of these, right? So the derivative of the sine is cosine theta, theta dot. Don't forget the chain rule. And then the derivative of the cosine is negative sine theta, theta dot in the j, right? Because the i's and the j's, they're all constants. And then the derivative of this, remember, YA is a variable. So you have YA dot, and you have the negative and the j from the equation. That's equal to 0. Okay, how many unknowns? Well, you don't know dB dot, and you don't know theta dot. But you should know y dot, YA dot. Okay, so what do? Well, you pull off the i's. So on the left-hand side, we're pulling off all the i's. Well, here's one. Here's a I term right there. That's this term right there. Negative dB dot cosine 30. Keep looking for i's. Oh, here's another I right here. So that's a positive 5 cosine theta, theta dot. Keep looking, there's none left. That equals 0. And then pull off all the j's. dB dot, negative sine 30. It's this piece right here. And then keep looking. Here's another piece right here. So minus 5 sine theta, theta dot. Keep going. Here's another piece right there. Minus YA dot equals 0. Okay, let's plug in what we know. We know that the velocity is going down. So if, just like you did in the ropes, if this velocity is going down, is YA getting bigger or is YA getting smaller, the distance? YA is getting smaller. Well, if YA is getting smaller, then his dot is a negative number. So YA dot is 4.2, and it's getting smaller, negative. This negative out here comes from the one that's already right there. So just be careful that you don't drop a negative sign. Okay? How many unknowns are in these two equations, right? So there's two equations right here. How many unknowns? 2. How many equations? 2. So you can solve it. So I'm going to show you how to do that with Mathematica. So here is a Mathematica file. Again, this stuff here was in that file vector4.nv. So that's already there. Once you bring it in, you have to execute it. And now I'm going to define some values that make it easier to type. A30 is 30 degrees. It's an angle of 30 degrees. I'm going to define down the incline this way, the vector this direction. This is down incline. Down incline is left, negative I, distance of cosine 30 degrees, and it's down, negative j, sine of 30 degrees. Up the rod is going to be a vector this way that points up the rod. Up the rod is cosine of theta, right? And notice I'm making sure that Mathematica knows that TH, which is theta, right? TH is a function of time. So I put in that bracket T. So it's going up, positive J. It's also going to the right, positive I, and it's going to go a distance of sine theta. Right? Remember, keep it variable so that it'll take a derivative. Okay, so here's the loop equation. I started in the corner. I go a distance dB, and notice how I'm telling Mathematica that it is a function of time. It's a variable. And it's going down the incline, and then 5 up the rod, and then it goes down, YA, down is negative J, down, the distance of YA, and that equals 0. Now, the only thing that you have to watch out for, you have to be a little careful. You don't want to just say 0, you want to say 0I, or 0J, or 0K, because you want it to be a vector of zeros, not just 1 0, right? You want the I is 0, the J is 0, and the K is 0. So that's an easy way to do it, 0I, but be careful of that. Okay, so after you write your loop equation, you take a derivative, right? So I'm calling it my V loop, my velocity loop, or whatever you want to call it. And it's a derivative of the loop with respect to time. So it takes the derivative for me, right here. So there's the derivative, right? Now, the i's are equal to this piece right here, up to the first comma. That's the I, and it equals 0. And then the j is the second piece right here, and it's also equal to 0. And then the k is 0 and 0. Okay, so you have two equations. The unknowns in here are dB dot and theta dot. So there's two unknowns and two equations. The other thing that I'd like to point out is the loop equation is useful for something. It has a distance dB. It has an angle, or YA, excuse me, YA. So here's the deal. If you have theta, you know theta is 50 degrees. You can get two equations off of this. You can get I here equals 0, and the j right here equals 0 to solve for two unknowns, dB and YA. So if you give me the angle theta, I can use the loop equation and find the distance YA and the distance dB. So you could say, well, I can do that too if I remember the law of sines, law of cosine. Yeah, sure, if you remember those, you can do it. But this is a general way of getting all of these variables where you don't have to remember the trig identities and that sort of thing. Okay, so That's that one. And then how do you solve it? Well, the way you solve it is you use this vsolve that was defined at the top, right up here, vsolve, that I provided for you. And you're going to solve this vector equation, and you're going to solve for the two unknowns, theta tick or theta dot, and dB tick, which is dB dot. And it solves it for you. Now, if you notice, it has the variables, right? It has th, it's got ya. I need to tell it what those are. Now that I've finished the derivatives, I can plug it in. So here, this is the easiest way to do it. So ya dot is a negative 4.2 because ya is getting smaller. And so that's why the derivative is a negative 4.2. Theta was given as 50 degrees. And then I just say, define those, and then say, tell me what the answer is, and bang, it gives me the same answer it gave me for special points. Okay, that's it for this one.